by now you have understood, right? One more exercise pending, we can do it. But here we will now see graphs. No, I did it up till 2.4. See, it's not about, first thing is keep this mindset. NCERT we should do. No questions about it. Apart from that, we have to do additional questions also from additional booklets and all. So those I will supply you. So many things are going across on my personal front. So I'm sorry, I said that I will be supplying one worksheet of motion, जो मैं आज दे दूंगा आपको, ठीक है? तो आज graphs सीखते हैं motion में. So by now you know V equal to U plus AT. All things we know are, these are all equations of uniformly accelerated. And we also know what is Y equal to mx plus c. ठीक है ना? So our discussion today starts with graphs. Kinematics of motion में graphs is the child who can understand graph well, he will tuck score graphs. And this is the basic of calculus of grade 12 also. So let's understand. We will have 3 graphs in this chapter. How many graphs? 3 graphs. Whether we are in grade 9 or whether we are in grade 11. How many number of graphs? 3 number of graphs. These 3 graphs are called ST graph. ST graph. S stands for what, beta? S stands for displacement. ST graph. If you see some American good physics books, they will write it as XT graph. वो डिस्प्लेसमेंट को x करके लिखते हैं, ST ग्राफ. Our next will be VT graph, and our third will be AT graph. That means we will have 3 graphs. One graph will be displacement versus time, one graph will be velocity versus time or maybe speed versus time, and one graph will be acceleration versus time. क्या इतना चीज आपको समझ में आया? ठीक है. In these graphs, whether we are in grade 9, grade 10, we are in engineering first year, our lookout will be to do 2 things. Number 1, to identify slope, and another would be to calculate area. Slope and area. So you know slope. What is slope? Slope is the inclination of a line. The indication is given by the angle. If the angle is acute, slope is positive. The formula for slope that we use as of grade 9 students are only rise by run. Right? आगे जाके बहुत सारे formulas आ जाएंगे. ठीक है? तो slope. And if you are interested in higher end mathematics, this will be the birth of what we call differential calculus. Though you may not understand anything, but remember this day and this what I told you today. Differential calculus, yep, 12 में जाके पढ़ेंगे, and area will be known as integral calculus. That means when you read these two in grade 11 or grade 12, remember differential calculus is all about slope, integral calculus is all about area. ठीक है? So आइए अब बात करते हैं the 3 type of graphs. Pretty easy in our this level of grade 9. So children, I am drawing first so that you all are kids. I am drawing it in this manner. 3 graphs I am drawing in this manner. But you know, in higher level, how they draw this graph? They'll draw 1 vertical and 3 horizontal. ठीक है ना? आइए. So, and please ask questions. There will be a lot of doubts in this chapter. यहाँ से बहुत doubts शुरू हो जाएगा. Okay. My first graph is a ST graph. This is a VT graph. This is a AT graph. In all these graphs, the slope will tell me some information. What is that information? Children, mug up. You need not mug up. Slope was what? Rise over run. I had told one more formula which we will use in physics. किसी को याद है? Y data by X data. I had said that slope is also Y data over X data. See, ultimately Y data is nothing but rise. Right? Y data over X data. और ये आपको दिमाग clear कर देगा. Displacement is measured in meter time is measured in second. Velocity is measured in meter per second. Time is measured in second. Acceleration is measured in meter per second square. Time is in second. Up till now, no doubt, children? Okay? Now, so we are supposed to, now let's see what does slope indicate here. Slope. Slope for what? ST graph. Y data by X data. What is Y data? Meter. What is X data? Second. Have you seen this unit before? Who has this unit? Velocity has this unit. Speed has this unit. That means a displacement time graph slope gives me speed or velocity. This is, so here beta Mentos खाओ और सीधा सोचो ये कौन है? ये है velocity, or it can also be speed. Children, did you understand the desi technique that I taught you? All of you could interpret why the slope will tell you velocity. Slope is rise over run. Rise over run, see, whatever rise you measure, look here, blah, 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 rise. That unit will be what? Meter. Whatever run, tla, 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 it will be in second. Meter by second is a unit which is held by velocity. Clear for your whole life? The so somebody tells you, graphically find velocity. So you should look, ST graph hai ki nahi? There has to be an ST graph. Otherwise, how will I calculate? But we can calculate. अभी इसको नहीं छेड़ा ना, एरिया नहीं छेड़े हैं. ठीक है? आइए इसको देखते हैं. If you look at the slope of this graph, then we have what? We have a VT graph. VT graph slope is X data. Sorry, Y data. Y data is meter per second divided by second, which is meter per second square. Who holds this unit? Acceleration holds this unit. Excellent. So your face should be smiling. This is none other than acceleration or maybe deceleration, whatever it is, or retardation. Clear? Okay. In differential calculus, slope is calculated as dy by dx. dy is the measurement on y, dx is a measurement on x. dy by dx. That dy by dx is slope. Okay. And when you actually see, the slope will be making a line like this with the x-axis. Now, this is the theta. So in other way, you try to do this by this, right? This by this is also called tan theta. So the slope is also tan of the angle. The slope is also the derivative out there. And since we are very small kiddos, for us the slope is rise over run. ठीक है ना? ये सब higher level classes में आएंगे. अभी आपको सर तोड़ने की जरूरत नहीं है. Okay, now let's come here. Let's calculate what is the slope. Slope of a AT graph is a meter per second square divided by second gives me a meter per second cube. Have you heard any unit so far whose measurement is meter per second cube? No. That means we say that though we can calculate slope, but here the slope is inconclusive. Does not give me any parameter which I have learned. Throughout my engineering, we have not used this, but there is a quantity what this measures. और बोलूंगा भी हंसना शुरू करोगे. Kinematics में इसका भी एक measurement है. This is known as a jerk, J-E-R-K. अब बोलने से ही हंसोगे. हाँ. So and this one will actually be written as dx by dt cube, right? Therefore, you will see many T-shirts written, "Don't call me a dx by dt cube." इसलिए ये आता. हाँ. So this is called jerk. इसको हम पढ़ते नहीं हैं कहीं भी. So this is, and how this comes? See, if you want to understand calculus, dx by dt is x is displacement. Displacement with respect to time is velocity. So not in your syllabus, just maza lo. If I write dx by dt, it means what? Velocity. If I write dv by dt, acceleration. Now this dv by dt can also be written as d dt of dx by dt, क्योंकि किसको डिफरेंशिएट कर रहे हो? वेलोसिटी. Velocity is dx by dt. This quantity is called d2x by dt2. So when you go to acceleration is what? Acceleration is, if you are differentiating acceleration, it is dA by dt. Acceleration itself is the derivative of velocity. So we can call this as d by dt of velocity, dv by dt. dv by dt is d2x by dt2. Another makes it d3x by dt3. That becomes jerk. ठीक है, वो सब आगे जाके पढ़ेंगे. So not to break your head on all these things. So please understand, this should be down your throat. What does the slope of each curve tell me? Only two curve slope give you data. The third curve slope does not give you any data. That's inconclusive. Is that understood? Why is it inconclusive? It gives me a unit called meter per second cube, which does nothing that I have studied so far. Are we fine? Shall we now talk about area? Chale? Aye. Anyone any doubt on this? Right, very good. Our next one is area curves. Shall I swap and go to area? Okay, let's go to area. Let's go to area. Right, now just plain have a look. Suppose I have a rectangle out here. This is my x-axis, this is my y-axis. Okay, this is my x-axis and this is my y-axis. Pay attention, I'll give you time to draw, don't worry. This is a rectangle. A rectangle is actually specified by what? A length and the breadth. What is the area of the rectangle? The area of the rectangle is a L into a bar. In other sense, I can say an x data into a y data. Perfect. An x data into a y data. All areas are x into y in 2D. All areas are x into y, whether it is triangle or anything. Keep this in mind now, and let's draw our three curves once again. Now I'll do it in that manner. Okay, graph 1, graph 2, and graph 3. Okay, the first graph is a ST graph, the second graph is a VT graph, the third graph is a AT graph. Okay, AT graph, VT graph, ST graph. Right, and I write their units. This is meter, this is second, this is meter per second, this is second, this is meter per second square, and this is second. All right, children, let's look at the first area. Area under a area of a ST graph. Now what is that area that we will see? Whatever area you calculate here, area is what, beta? X data into Y data. So you are getting what? You are getting a meter multiplied by a second, ms. Have you heard anything about it? ms, any quantity whose unit is ms. Nahin? Inconclusive. Inconclusive. Let's see the area here. This was area for ST graph. This is area for VT graph. So here we will have meter per second multiplied by second, second cut, you get meter. Wow, this is displacement. Or this can also be distance traveled if the motion is straight line. In the previous two, what all did you calculate? Velocity, acceleration. You could not calculate displacement. Displacement comes from the area graph. ठीक है ना? अच्छा, अब इसको देखते हैं. इसका एरिया क्या हो गया? AT graph. This is meter per second square multiplied by second square gone. Yes, you actually form something which is known as velocity. Now some interesting observations, and then I'll drink water. I'll give you time to write. जरा सुन लो मुझे, और 2 minutes सुन लो मुझे. हाँ. Try to recollect the previous graph, and I'll again swap back. Imagine that here we have got the slope curves. The third graph on slope did not give anything. The first graph on area did not give anything. It's a crisscross relationship. Are you getting it? This one gives you velocity. And there on the second one, or sorry, on the last one does not give you anything. This one gives you velocity. If you see the first one has information on slope, no information on area. If you see the third one has information on area, but no information of slope, which makes this boy very, very loved of the parents. He has an information for slope, he has an information. ये सबसे ज़्यादा आता है ये graph, which is known as the VT graph. A VT graph, even when you will be solving the equations of motions graphically, we will be using VT graph. VT graph is a double-ended spanner. इस साइड से भी नट खुलता है, उस साइड से भी नट खुलता है. A VT graph on slope gives me what? Acceleration. And since it is a VT graph, I can measure V from the graph itself. And the area gives me displacement. Now you note down whatever you want to note. And if you have queries, you can ask. Okay? Want me to go back to the slope curve? But take your time to draw nicely. Lot of questions will come in your mind. Now we have not yet drawn any graph. What have we drawn? We have only plotted the axis, bacha. Graph we have not drawn. Graph is when the curve comes out here. Rayan, samajh mein aaya to beta? We have not drawn any graph. We have just plotted axis. Graph is when you see the run rate wala curve coming up. Okay? Slope and area. So whenever a question comes and they say solve graphically, you should forget the three equations of motion. Zero milega aapko if you use. You have to just think graphically, and your eyes should be fed on slope, 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 area, area, area. The answer is there only. It is whether you are able to find out or not is your choice. This works in three cases. This is a portable tire inflator. This works as a power bank if you have switched on. This works as a flashlight. कितना कुछ काम करता है ये? नहीं, स्पीकर नहीं है. Which one? A previous slide. Okay. Oh.
Yes.
I carry, like, I travel roadways a lot. I keep two inflators. This is portable. This cannot inflate all the tires of the car. Maximum one it will inflate. After that it will die down. I've got another inflator which is jacked with the car battery. That can inflate. Then jumpers. Then puncture kit. All should be there. Otherwise you're traveling from here to Delhi Valley. You need that. Temperature is so much. Oh, questions we are not there at all. We are like our questions are like our teenage boy. We are just now feeding lactogen. You think that we are Cerelac खा रहे हैं अभी हम लोग. We are at Cerelac stage. But take Cerelac properly so that nutrition becomes good. Shall we? Next one. Okay. Yeah. This is not at all questions. These are, if you understand this, you will answer every questions fatar. I take a lot of time on the first chapter every year. If you see, you are studying with me from April. We have not missed a single physics class, nor did we hack. But we are still on chapter 1. If you understand this chapter good, you will not limp in grade 11. Otherwise, you will be limping very badly. And you were just kids of grade 8 to whom all these concepts had to be inserted. Acceleration, this, that. Till now, you were drawing 3 zones of a flame. From that level you have come here. 8 to 9 is a shocker in life. 9 to 10 is not a shocker. 8. Done? Shall I go ahead now? Okay, aa jao. So let us draw one graph. We are trying to plot a graph which is, this is a ST graph, children. ST graph. Okay, this is a ST graph. Let's see some scenarios now. Okay, ST graph. We have spoken about something called uniform motion. A body is said to be in uniform motion if it travels in a straight line and covers equal distances in equal intervals of time, no matter how small the time intervals are. Matlab kya hai? When time was 0, displacement should be 0. If you have covered 5 meters in 5 minutes, 10 meters, 10 minutes. Therefore, a uniform motion curve will always be a straight line. This line this line may be at a 45 degree, may not be. Maybe at a 45 degree, may not be. Understood? Now we will put mathematics. Wait. What was my equation? Now I'll answer Ryan's question. My graph was y equal to mx plus c. Could you find what is c here? C is 0. That's why the graph is not touching the y-axis. That means in this particular case, my graph is y equal to mx. Do you agree? If the value of m is made as 1, then y is equal to how much? X. Y equal to x is a curve which will be always at 45 degree. Now you just think all equations y equal to 2x, y equal to 3x, y equal to 4x will always be straight lines passing through the origin because they don't have any y-intercept. You ask yourself a question. When the journey started, we are measuring your displacement as 0 when time was 0. You are not like a tortoise that you were parked here and from here you started. So it doesn't have a y-intercept. Uniform motion. मजा आ रहा है? समझ में आया? So if this motion is non-uniform, then my curve will be always like this. Now look at this non-uniform motion. What do you tell about the speed here? Look, we'll discuss that. We'll discuss that. Okay, there's a non-uniform motion. Okay, and let's say I have another graph which is like this. This is like all the illegal parkings of our society. He parked in my parking yesterday. Today also the car is there itself. Tomorrow also the car is there itself. Stagnant. No motion at all. Or you are at a traffic light. Time is passing by, but there is no movement on the displacement axis. That means rest. समझ में आया? तो इसको हम क्या बोलेंगे? What are we going to call this? This is uniform motion. Okay. This is what? Non-uniform motion. And what is this? Rest. Rest. Now the challenging part. Now start attacking these. Okay. Now start attacking these graphs with the perspective of slope. Don't write. Please understand first. We'll attack these graphs with the perspective of slope. Right? What type of graph are we dealing right now? What graph? ST graph. If you forget, always remember. What should the slope tell me? What should the slope of an ST graph tell me? Velocity. क्या हो गया? 1 minute में battery down. The slope should tell me velocity. Right? Let's look at this curve. Now here is where mathematics will challenge your thought process. We call this as constant slope. The slope is constant. What did I say? Slope is constant. आप बोलोगे नीचे आ रहा है. How is it constant? Slope is constant. अच्छा, how to understand? Make a bacha sit here. Will the bacha face any bump while falling? So slope is constant. But you all are not applying mathematics which I taught you. What is that mathematics? आप लोग ना apply नहीं करते हो knowledge. To check whether the slope is constant or not, draw some positive direction of x-axis wherever you feel like. Right? Don't you think this angle theta and this angle theta must be same? Corresponding angles, transversal parallel lines, class 8. This angle is equal to this. So the slope is constant. Therefore, this is uniform velocity. Now go back to the definition of uniform velocity and clear your mug up. A body is said to be in uniform velocity if it travels in a straight line and covers equal distances in equal intervals of time, no matter how small the time intervals are. Is it anything different from uniform motion? Not at all. The graph proves it. There's that x-axis कौन बोला है यहीं पे है. A fighter pilot is constantly on the space. For him, the axes are changing constantly. But wherever he draws an x-axis, the y-axis has to be perpendicular to it. That's simple. In 3D, how do I lock a missile? Anything can be XYZ. But whatever is x, the y has to be perpendicular to it. Use positive direction. This is a vector. The vector can always be translated. Did I tell you in first class? So you are trying to see whether the slope is uniform or not. Please understand, this is uniform slope. Two ways to understand. If you don't understand theta, put a bacha. If this line was like this and like this, then the bacha would have, he would have fallen down in this manner. He wouldn't have had a mazaka ride. Understood? So this is uniform motion, uniform velocity. Now question arises, sir, what about this non-uniform? Can we calculate slope here? Can we calculate slope here? Yes, this is the heart of differential calculus. How to calculate slope for a curve? And what will slope tell me? Slope is going to tell me the nature. First of all, this is non-uniform motion. Is the body picking up speed or losing speed? My question is that. You won't be, how do you know? How do you know? How do you know it's picking up speed or not? No, I'm saying this is non-uniform motion. What is non-uniform motion? Is this sound with this graph matching? No, no, no. How do you know now? Sir, if you would have given us some knowledge about velocity, we could have told. If I tell you that the velocity is increasing, velocity is increasing, that means velocity is not uniform. How to find that? Okay, for curves, we say that you can't define slope straight away. You define slope at a point. Slope at a point. So let us take some points on this curve. This is a point. This is a point. This is a point. This is a point. At 4, these all points resemble to some time. Let's check the velocities at these times. If the velocities are increasing, this gadi must be picking up speed, means non-uniform motion. The way we actually calculate slope here is, we actually plot what is called tangent to the point. Tangent, you know, tangent is a line which touches a graph at only one point, not in grade 9, just for your knowledge. Tangent. Right? Out here the tangent becomes, this is the new tangent. Agreed? Here the tangent becomes like this. Here the tangent becomes like this. Right? Now for each tangent, let us estimate the slope. Positive direction of x-axis, positive direction of x-axis, positive direction of x-axis, positive direction of x-axis. And I'm going to name these angles, and I'm deliberately name it with Greek letters so that you get more confused, and only you'll understand. This is angle alpha, this is angle beta, this is angle gamma, and this is angle delta. Tell me, what is the, how do you see who is a greater angle, who is a lesser angle? Can you just arrange them? Tell me, how do you arrange them? Who is a smaller angle out here? Alpha. I'm only teaching offline children. I don't teach online children. Yeah. Alpha, they somehow hacked my signal and logged into my classes. Alpha. And for that, I send a penalty invoice to their parents and they pay it to me. Alpha is, after that, the greater angle is beta. the more greater angle is gamma, the more greater angle is delta. Agreed? What did I tell you about slope? The angle is an indication of the slope. Put a child on alpha ladder and put a child on beta slide and alpha slide. Where the child will slide more faster? Beta slide. Slope is more. Gamma slide, he will slide even faster. And at delta, he will say, "Bhaiya, mat bito, main gir jaunga." He will be more faster. So if they are representing velocities, what is the nature of the velocity? Slope represents velocity. And the slope is continuously increasing. So the velocity is, this is Yamaha, whoom, 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 it's going like that. The speed is increasing. You have to feel the graph by the way you do it. समझ में आया? इसका उल्टा भी तो हो सकता है. What is the ulta one of this? The ulta one of this is like this. Okay. So let's say we make a plot now, and our plot is something like this. Let's say our plot is somewhat like this. Got it? Now, in this case, let me find out some points. Say this is 1 point, this is 1 point, this is 1 point. And let's draw some tangents at these points. Tangent 1, tangent 2, tangent 1, tangent 2, and a tangent 3. If you see, all these are obtuse angle with positive direction of x-axis. It's negative. The slope is negative. Slope is negative means not that the velocity is negative. This is, the velocity is negative means the vehicle is moving in the opposite direction. And also the slope is reducing. Also the slope is reducing. So it is moving in negative direction with a reducing speed. Like sometimes we put our reverse gear, that you do na, and then slowly slow down. Or subeh hota hai na, someone going to the airport, and your sleep wakes up. It is that one. Though not required in grade 9. Just for our understanding, we don't have curves. I'm saying in curves also slope. Now to calculate these slopes, we invented differential calculus, which is beyond your scope now. Your slope is this. This is not in your syllabus. Let's talk about this. This is at rest. Put one bacha out here. What does the bacha do? Stays there only. What is the slope? What is the slope of this line? 0. Why 0? Rise over run. You don't rise, you're only running. Slope for a ST graph tells me what? ST graph velocity. I am at the Gachibowli signal for last 10 minutes. What is my velocity? It cannot be, because if I am at rest, velocity should be 0, proved by the graph. Here slope is what? What about my slope here, children? Slope is 0. Slope is 0. Slope 0 means velocity 0. Don't write slope 0, velocity 0. Looking at the graph, if this was a VT graph, the slope would have told you about acceleration. Mind you. Very nice. This graph. Let's try to see this graph now from my auntie's house. I'm seeing it from my house. Now let's see this graph from my auntie's house. Right? Auntie's house is a VT graph. Can anybody tell me what the plot will be? I'm keeping my green ink ready. I'm saying this scenario on this graph. This scenario on this graph. सबसे पहले ऐसे questions whenever I ask, what did I ask you? Draw this scenario on this graph. Are the two graphs same? No. One is ST, one is VT. Okay, he's asking me this scenario. This is a VT graph. What is the graph? Straight line. Represents what? The slope represents velocity. And the slope is constant. So the velocity is constant and uniform. So on this graph, the plot will be like this. Constant. And constant velocity means, do you have a V and a U? No, there is only one V. Acceleration has not taken birth. What is the slope of this graph? What is the slope of this graph? 0. And what is the slope of a VT graph? Acceleration. So acceleration is 0. Yeah, this is a meter per second, meter per second. So this is uniform velocity. And if we look at the slope of this graph, then what should be the slope? Time should be in second. Yeah, sorry. Time should be in second. Sorry, bacha. Thank you. Time should be in second. So if you see the slope is meter per second square, which is actually talking about acceleration. And the slope is 0. Because if my velocity is uniform, how can acceleration be born? If my velocity is uniform, how can acceleration be born? I'm going cruise.
Non-uniform motion, there will be acceleration.
Non-uniform motion is always an accelerated, but non-uniformly accelerated. So you don't study this. Here there is not one A. A1, A2, A3, A4, A5, A6. So you can't use SUVAT. Your SUVAT uses only one A. That's why your chapter is equations of uniformly accelerated motion in a straight line. But when you are driving, look at your accelerator. Constantly. But when you are on cruise, the accelerator is locked. Acceleration 0, velocity constant. Ek kadam, sleep on way. Feelings is very important. Understood? Let's see one more graph, the favorite VT graph. These were all on ST, ST, ST. Okay? Let's see some more VT graph. Acha, आइए. Let's see a VT graph now. Okay, I hope you have developed that much sense to help me in this one. I have a VT graph. Should I write the unit? I should not, but I'm writing still. I have a VT graph. I have a AT graph. Does the slope of AT graph tell anything? No, 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 no. Nothing. Now my plot is very interesting. My plot is think simple step by step. What is the graph? Velocity time graph. What does the slope tell me? What is the plot? Straight line. This is called straight line. Straight line is a line whose slope is constant, not 0. विश्वास नहीं होता है? Put Rishika out here. Constant. विश्वास नहीं होता है? Draw some parallel to x-axis and look at the angles. Same. Right? So I can write here something which is like this. Children, disagree if you want. Slope here is constant. Yes or no? Slope is constant. What is being represented by slope in this graph?
Yes.
Now I say, plot this scenario here. Straight line. Acceleration constant, ना? Correct? Acceleration constant. यहाँ पे हम slope नहीं नापते हैं. Perfect. Did you understand? Can we see one more scenario and then we'll see one equation plotting also. Okay? Let's see one more scenario. Chalo. A daily scenario. Right? Now imagine everything is a straight line from here till IKEA. Everything is a straight line from here to IKEA, right? And whenever we accelerate uniformly, right? So we're trying to plot this on beta and ST graph. Mind you, what graph? ST graph. We start from our house, right? And like this, we have reached the toll gate. What is this motion telling you? Yeah? This is the slope. I can read the slope of this graph. The slope of this graph tells me what? Velocity. So this is uniform velocity. I reached our toll gate, our TSPA toll gate. Agreed or not? Right? At TSP toll gate, there are many vehicles in front of me. So I went into rest. And this is in a normal civilian road. Now I have got the ORR. What should I do? My speed should increase. My speed should increase. We can't talk acceleration in this graph at all. My speed should increase. If I'm going at the same speed, that means after this portion, the journey that I'll take, that slope and this slope should be same. If I'm going, two lines having the same slope will be parallel to each other. They are having the same slope. A-tower guard ladder spark, B-tower park ladders. They are having the same slope. We bought it from the same manufacturer. But this time we told the manufacturer, our children have become very naughty. Please increase the slope. Let their hands and legs break. So we want to increase our speed. So if you increase your speed, don't you think now your slope will be much more a steeper rise? This is also uniform velocity. This is also uniform velocity. But this is a velocity with a greater slope. Gari is going fast. And now I have reached the second toll post. Again, rest. After that, there will be a lot of people merging from the Kondapur side to me. So I'll be going at speed, but speed will be lesser. Maybe lesser than this also, because I'm heading the Shilpa flyover area. So, but ours is always uniform velocity. Now look at this velocity and this velocity. This is also uniform, this is also uniform, but here the value of the velocity is less. Agreed? And then I have reached IKEA. And after reaching IKEA, my car is parked. Right? At this time, there is a lady in your life known as your mother who will start calling. You have any interest to have lunch or not? Come home quickly. We'll come home quickly. But we are traveling in a straight line to IKEA, huh? Mind you. So now we will be traveling on the straight line other side. So whatever velocities we will have will all be negative velocities. Negative velocities. Negative velocity does not mean speed is less. Negative velocity means it's just going like Mickey and Donald is going on the backside, the same speed. Negative velocity. Negative velocity means negative slope. Negative slope means obtuse angle. And such that there is one straight line from IKEA to my parking. Imagine, I'm not drawing this scenario again. I don't have space. Now there is one straight expressway from IKEA to my parking. And my mother has already given me ultimatum that you better come down home and come immediately. So how do I come home? I have more raised down my car. I have raised down my car and I have come down in a very short span of time. So if you look at the time, this is so dangerous driving. I took this much time to go to IKEA. I took just this much time to come back to my home. I was seeing it. Right? Mark. And these are all obtuse angle. Draw a positive line with the X. These are all obtuse angle. Showing that the slope is negative. But the slope is uniform. Even बच्चा sits here, he will say, पहले मैं मासी के घर जाता था, अब मैं बुआ के घर जाता हूँ. ऐसे है ना? Slope तो यूनिफॉर्म है. मजा आ रहा है कि नहीं? ये होता है फिजिक्स. तो रटकू तोता बन के नहीं पढ़ सकते हैं. You can't be a parrot to learn physics. You have to feel it. I wish somebody told us. And by teaching so many students abroad, because their physics is so descriptive, it's not about finding angle and velocity. Our children will score very nice. You got 22.1. Yes, ma'am told 21.3. She'll give full marks. But this knowledge is not clear. This knowledge should be clear. Clear? So we will get problems where we have to calculate. Let's say we mark our journey like this. 0, A, B, C, D, E, F, G. Now little bit answering Adya. She said, what type of questions come? What is the nature of the journey from 0 to A? The body is in uniform velocity. How do you compare it between D to E? Both are uniform velocity. However, D to E being a lesser slope, the body is maintaining a lesser velocity. How about F to G? Uniform slope, negative slope, the body is moving in exactly the reverse direction with a very high speed. Right? Calculate the time, so a lot of times will be given. Now they might ask us, calculate the velocity between B to C graphically. Between B to C what? Graphically. So you put one line here, put one line here. Yes or no, children? This is your rise and that's your run. If you calculate rise over run, then you'll get slope. And we should get positive. So think you are here. Even if you are rising positive, run is positive. Now look at the slope here, right? Obtuse angle, but the slope should be negative. Okay, let's calculate this slope. First, we have to reach G, like the rook of chess. First, we will run positive, but our rise is negative. Here, slope automatically will be negative. Here also we will get a slope. Acha, see, why is the slope less here? Now you will say, sir, you only said that the measure of the angle gives us the slope. Slope is what? Rise over run. The run is very big, the denominator is big, so the quotient is small. Rise over run. Here see, rise is big, numerator is big, denominator is small. Therefore, quotient is very large. क्या कर ले, सीख लिया तुम लोग यार, मैं कोई दुख नहीं है मेरे को, ठीक है? And if the rise and run are same, then it's an isosceles triangle. It should be at 45 degree. This in higher mathematics we will do. Yeah, 1 होने से isosceles हो जाएगा ना. Isosceles base angles are always 45. Common sense. Angles opposite to equal sides are always equal. 90, 45, 45. ठीक. We still have time. ये समझ में आया. ऐसे problems हम करेंगे. We will have a lot of values with this. But this was what? This was a ST graph. Since this is an ST graph, we cannot talk anything in terms of area in this curve because area does not give us anything conclusive. Area is massa, meter second, and that type of an animal we have not seen so far. So let's change this graph now. Okay? And let's go to your interesting graph. Say your first equation. Your first equation says V is equal to U plus AT. Okay, how we read this is, we read this like this. V is a function of t. Here t is the variable. Just like you read. What do you read? You read a polynomial y equal to mx plus c. Right? This is the variable. Y is a function of x. Here v is a function of t. Why, you ask? At different time, I will have different speed, bhai. So my input is, अरे 8 बजे कितना speed था? Input is time. So let's rearrange this equation and write it mathematically, not like physics. In mathematics, I would prefer to write it the velocity v as a function of t. You remember polynomial p of x? This is v of t. X was the variable, t is the variable. So this is v of t. V of t is given by at plus u. Okay? A little bit if you want, little bit, then this is y of x to m of mx plus c. Mx plus c. Now based on this knowledge, let us plot this graph. Right? Let's plot this graph. Chal. Now what is this? This is t, right? And what is this? This is v. Agreed? Now we know that these graphs always have a y-intercept which is c. So here the y-intercept is u. U is also some velocity only, na, initial velocity. So let's say this is u. Look at the nature of this graph. Assuming acceleration is positive, then the slope is positive. The graph should make an acute angle. The graph should make an acute angle. Hey, Rehansh, देखो, नहीं देखने से मजा नहीं आएगा. The graph should make an acute angle. So I am saying let that graph be something like this. This is what in mathematics we have learned. The line should have gone like this. But in physics, I will not draw like this. I will be drawing only till this much. Why? What stops me from extending it here? Because you are insan, human. Beyond this, time is negative. And in negative, only Bhoot, Pistash, Yaksh and Gandharv can walk as per Hindu mythology. Humans cannot. Negative time में जा सकते हो क्या? नहीं जा सकते. So our graph is limited till here. मजा आया? Otherwise, the graph should have gone till here. In mathematics, the graph is possible to go here, right? So I'm drawing this graph now up till here. Agreed? So you will not disagree with me that this much portion is U. This much portion is U. This yellow line is called the graph. Yellow line is called the graph. And now we will go a little bit area. We are very, very hungry on area. So when I say area tells me this, area under the graph. Area under the graph. So the graph is like one danda. Everything below it is the area. Okay. What is the sap you are seeing? What is this sap? Shape. Trapezium. Don't you think this is also a rectangle and a triangle? Agreed? Very good. So let's give it some name. O, A, B, C, D. All we are supposed to calculate the area. And this area should give me displacement. Yes or no? So let's calculate the area. Batao bacha, this much portion area will be what? U into T, U into T. And area of the triangle, base into altitude. Altitude is what? Let us see. Altitude is BC. I don't know what is the value of BC. So bad. So bad. I don't know what is BC. No, wait. What is the slope of this graph? This is what graph? VT graph. So this slope should be BC divided by AC, rise over run. Slope of this graph is nothing but acceleration. BC is BC and AC is T. So BC's value is equal to 80. That means this is half 80 into T. This is UT plus half 80 square, darling. Now we prove our second equation of motion. Graphically. Majo aayo? Understood or not? Yes or no? No. Yes. So this is area of a triangle. What is area of a triangle? Half into base, half into T into BC. BC we don't know, but we know this. Calculate the slope. Slope is what? BC by AC. This is VT graph. So slope must be area. No, acceleration. Acceleration is BC by T. So BC is 80. So put in place of BC, put 80, and this T is there. The T square S equal to UT plus half at T square. मजे आयो? Distance calculate हो गया? Defense rests its case, Your Honor. Your next witness, please. I have nothing more to say.